Now, by your method of choice, so you could say I choose to see if it factors, and then if it's factor, we'll go through and solve by factoring. But you do know that the quadratic formula always works. Just the problem with the quadratic formula is you have to be careful, and there was a lot of you that just messed up big time on the quadratic formula. So let's go through this. I'm going to choose to do the quadratic formula with this one. So remember, quadratic, what makes it quadratic is the square. It's x squared. And quadratics have this form, ax squared plus bx plus c, where a, b, and c are the numbers in front of the variables. So looking at this, before we can even do the quadratic formula, very important, you have to get a set equal to 0. So I have negative x squared minus 2x. I'm going to add 20 to both sides. Now you can't combine 20 with those things on the left. Those are not like terms, so I have plus 20 is equal to 0. Did everybody get that? Now, piece by piece, we're going to be going kind of quick today. This is a review day. We're going to go through and say what A, B, and C is. So what's A, guys? Negative 1. Now, guess what I saw on the quiz? People wrote negative 1x squared. No, A is the number in front of x squared. B is equal to what? Negative 2, and C is equal to 20. Okay. All right, so now I'm going to go ahead and use the quadratic formula. And the song goes x equals negative b plus or minus the square root of, parentheses important, b squared minus 4ac all over 2a. Okay, so then we're just plugging it in, so we've got to do it carefully, and most of you just messed up on the algebra here. Okay, so let's go ahead and plug this in. Showing all my work will really help. I was able to get like lots of good feedback on the quiz. So the opposite of b, the b was negative 2, so what's the opposite of b? Positive 2. Does everybody see how negative of negative 2 is positive 2? 2 plus or minus the square root of b squared. Now you should be watching because every single one of you need this. So make sure you're watching. This is a good thing. I already know how to do this. No, you don't. Negative 2 squared minus 4 times a. A is negative 1 times c. C is 20. And that's all over 2 times a. So 2 times negative 1. Okay, any questions? Now we have to be really careful when we continue to simplify. Now this is x is equal to. So we have x is equal to 2 plus or minus the square root. Now this is so important, guys. On the quiz I saw some bad things here. What's negative 2 squared? Positive 4. I saw people write negative 4. Now you have to type it into parentheses with your calculator. So it's positive 4. Now looking at this part, this is where the most common errors come in with signs. This is negative 4 times negative 1 times positive 20. So type that into your calculator. Negative 4 times negative 1 times positive 20. And what do you get? Okay, positive 80. So that means plus 80. If it would have been negative 80, you would have done subtract 80. And then that's all over 2 times negative 1, which is negative 2. Questions on that? Continuing to simplify then. Continuing to simplify here. We have x is equal to 2 plus or minus the square root of 84. 4 plus 80 is positive 84. All over negative 2. Now guess what? Some of you stopped there. Not true. You got to now go off to the side and say, I got to simplify this if possible. So I'm going to go off to the side and do a little aside. I'm going to do 84. Now if you type it into your calculator and you get a decimal, then you have to do it by hand. Okay? You have to break it down. So 84, break it down into its factors. So 84 divided by something. Give me some factors, people. 84 divided by what? 4 is 21? So 4 and 21 are factors. Okay, good. All right, does 4 break down further? 2 times 2, very good. Does 21 break down? 7 times 3. Are those all prime numbers? We're down to our prime factors, so we're done. Now we're pulling out groups of 2. Now I'm hopefully fixing common errors that you're making. Pulling out groups of 2. So we're pulling out those 2 2's. Now guess what I saw 90% of you do? Multiply them. 2 times 2 on the outside. Not true. The only reason we were able to pull those out is because there was 2 of them. Because really what we're doing, guys, is the square root of 4, which is 2. So we're pulling out a 2 for those 2 2's. Can 7 and 3 leave the house? So we still have a house, and then we have 7 times 3 left underneath, which is 21. So hopefully you understand, guys, this became that. So I'm going to rewrite it. 2 plus or minus 2 square roots of 21 all over negative 2. Questions? Ask them if you do. All right, and now looking at this, do all 3 terms simplify by something? They all divide by what? So this divides by 2 and becomes 1. It doesn't go away. This divides by 2 and becomes 1. This divides by 2 and becomes negative 1. Okay, so we have x is equal to 1 plus or minus the square root of 21. 1 times 20, square root of 21 is just 21. Square root of 21. All over negative 1. Now, they on an ACT or on a test, if it was multiple choice, they wouldn't write it like this. What they would do is, and okay, we can split it up and say x is equal to 1 plus the square root of 21 all over negative 1. X is equal to 1 minus the square root of 21 all over negative 1. Now, anything divided by negative 1 is just itself except for negative, right? So we've got to divide each of these things, each of them, by negative 1. So what's 1 divided by negative 1? 1 divided by negative 1 is negative 1. And then what's positive 21, square root of 21 divided by negative 1? Negative square roots of 21. Does everybody see how I did that? Divided that by negative 1 and that by negative 1. Getting it like this. There's one of my answers. That's how they write it on an ACT. That's how they write it. Now over here, what's 1 divided by negative 1? Negative 1. And then what's negative divided by a negative? Positive. So we'll have plus the square roots of 21. So we also have that answer. Any questions on that? 2 answers make sense. We had a quadratic degree 2. We should have 2 answers. Okay, questions. Moving on. All right, factor the expression completely. We're going to do problem. I'm going to do problem 2 with you. So if you do it, you won't have to do it on your worksheet because I just did it for you, with you. So we're going to factor this one. It's x squared minus 49. Now, once again, remember, quadratics have the form ax squared plus bx plus c is equal to 0. The first thing I look for before I do anything is do each term have something in common we can pull out. X squared minus 49. Guys, there's nothing in common we can pull out. So we got to move on. And we're going to do what multiplies to be, well, first of all, what's a in the problem? 1. It's in front of x squared. Okay, well, what's b in this problem? Is there a b? No. So 0. And then what is c? Negative 49. Questions on that? Now we're doing what multiplies to be a times c. This is factoring, guys. What multiplies to be a times c and adds up to be b. That's what you got to ask yourself. A times c is negative 49, right? 1 times negative 49 is negative 49. What is b? 0. Is everybody following me? Okay. Continuing onward here. Continuing onward. Sorry. All right. So now we're looking for factors that multiply to be 49. Ignore the negative for now. 1 times 49 multiplies to be 49. What else?
7 times 7.
Oh, 7 times 7. Are those the only factors? Yes. Okay. So let's go ahead and see. Which ones could add up to be 0? Possibly. 1 and 49. Could that ever add up to be 0? No. How about 7 and 7? Could add up to be 0. 1 would have to be a negative. Okay, well, let's see if that works. It has to work in both cases. Is negative 7 times positive 7 negative 49? So it works there. And then once again, negative 7 plus positive 7 is equal to 0. So it works in this case. So we know our factors are truly negative 7 and positive 7. All right, so now we're to drop and break. You write down the original problem, x squared, and it happened to be minus 49 is equal to 0. So you're dropping down the end terms. Well, guys, these are the end terms, right? We're missing the middle term, right? Is everybody following? That one's tricky. Our end terms here are x squared, drop. So we're dropping those down, including the sign with the negative 49. And we're breaking down the middle term. Well, there's not a middle term there, but there's a 0 in there. So we're still breaking down the middle term. And we're rewriting it as our factors, but with x's, true? So we have negative 7x plus 7x. It was a negative and a positive. Some of you forgot the x's. Okay, now we'll group the first 2 terms, group the second 2 terms, and then factor out of those groups what you have in common. X minus 7x, what are we going to factor out? An x. Does everybody see that? They both have an x. So now we're going to write what's left inside. Let's say you didn't know. Let's say you're like, I don't know what's left inside. Go back through and say I divided each term by x. That's what you did when you pulled out. What's x squared divided by x? X. What's negative 7x divided by x? Negative 7. Does everybody see that? Continuing. So looking at this group, what do we have in common? A 7, and there's not a negative in front, so we don't need to pull out a negative. So we're just pulling out a 7, a positive 7 in fact. We're pulling out a positive 7. So then once again, if you're like, well, I don't know what's left inside, go back through and divide each term by what you pulled out. 7x divided by 7 is x. Negative 49 divided by 7. Negative 7. Okay, check your safe haven. Check your safe haven. Are we safe? Yes, we have inside the parentheses is exactly the exact same thing. Safe haven. Even if the sign is different, you've done something wrong. So now we can pull out the safe haven. X minus 7, and then those divided out, so that left you with x plus 7. And it didn't say to solve by factoring, it just said to factor, so we're done. We could solve this one easily, though. Makes sense, everyone. Okay, a couple more, and then I'm just going to let you work the rest of the time, but stay with me. Here we go. No questions on factoring. Okay? Factor each expression completely. 25x squared minus 5x. Well, the first thing we do, it is quadratic. It better have 2 solutions, yeah? Everybody, watch this one so that you don't ask. Okay, so we should have 2 solutions. Well, the first thing I want to look at is, in the very beginning, is there something we can pull out in common? The greatest thing. What do they both have? They have a 5 and an x. So in this one, guys, I'm going to pull out a 5 and an x and write what's left inside the parentheses. Now, let's say you didn't know what was left inside the parentheses. Go back through and divide each term by 5x so that you can see what's left. 25 divided by 5 is 5. X squared divided by x is x. Now, guys, careful here. Negative 5x divided by 5x is not 0. What's anything divided by itself? 1. So this one is negative 1. Now look at our factors. Are they linear? Are they degree 1, each of them? We're done. All we have to do, we're done. We're factoring. It didn't even say solve by factoring. It said factor. So we're done. Now notice, guys, look how cool it says. You can check your answers. Does everybody see how I did that first? Yeah or no? Okay, any questions? We can check our answers, because if you multiply that back in, you better end up back where you started. 5x times 5x is 25x squared. 5x times 1 is negative 5x. Is this what we started with? Wow, so you can check your answers. Kind of cool. Kind of cool. Okay, moving on to the next example. So guys, when you're factoring a quadratic, the first thing I look for is there something in common I can factor out in the very beginning, because a lot of times, if there is, usually you're done. Okay. Last couple examples, I'm just going to let you work. Here we go. It says, use the zero product property to solve for x. This one should be a no-brainer, easiest one on the whole quiz, yet 80% of you missed it. So that's why I'm doing this one. Here we go. So, use the zero product property to solve for x. So we have 2x plus 2 times 3x minus 2 is equal to 0. What do you notice? Those are linear factors. Are they already factored? Yeah, so we don't have to factor it. All we have to do is say, we know that the zero product property rule works here, and we can set each of those linear factors equal to 0. So we have 2x plus 2 is equal to 0, and we also have 3x minus 2 is equal to 0. Now let's solve for x in each case. Solve for x in each case. Subtract 2 from both sides. So we have 2x is equal to negative 2. Divide by 2, and x is equal to what? Negative 1. Did we find one of our solutions? Yes. Now let's go find our other solution. So we're going to add 2. So we have 3x is equal to positive 2. To solve for x, at this point, we'll divide both sides by 3. So we get x is equal to 2/3. I want that answer, not the decimal. We got 2 solutions. That makes sense, because if we multiply this through, guys, our highest degree would be 6x squared, which is quadratic. Does that make sense? 2 solutions. Okay. Now, notice this, guys. This is actually a problem on one of the worksheets I noticed, and a lot of you didn't know. And I've never stated it, so it's not your fault. It's mine for not saying it. The only time you can actually split these up and set them equal to 0, and set them equal and actually solve is if it's equal to 0. So on the homework, I saw a problem where it said, Johnny Cakes used this problem, and he solved it like this. X plus 2 times x plus 3 is equal to 4. So he split it up and said x plus 2 is equal to 4, and x minus 3 is equal to 4. Guys, you can't do that. You can't do that. It's only if it's equal to 0. Does that make sense now on the rule on that? Okay, so if it's equal to anything, you can't solve that way. So guess what? We would have had to solve this one the long way. We would have had to multiply it out, combine like terms, and then bring the 4 over so that it's equal to 0, because it would have been quadratic, and then solve using the quadratic formula. So does that make sense on the difference? If it's equal to 0, split them up, solve. If it's not equal to 0, you can't do that. Are we all okay? All right. Okay, couple more here. What is f of 25 given f of x is equal to the square root of 50 minus x? Okay, so we're asked to find f of 25. So notice, guys, instead of an x, there's a 25. So f of 25, we're just substituting in 25 for x. So we're going to have the square root of 50 minus what? Minus x, which is 25, okay. So everybody see that I'm substituting it in for x. Are we all okay here? So then we know that f of 25, that just means what's our function at 25, at the value of 25, f of 25 is equal to, okay, 50 minus 25 is 25. So our function at 25, f of 25 is equal to, what's the square root of 25? 5. So f of 25 is equal to 5. Any questions on that? Okay. All right. So what I'm going to have you do now so that we can all wake up is stand up, walk around the room, say hi to your friend, give them a high five, sit back down, we'll keep going. Okay? Ready, set, go. I promise we're getting down to the end here, guys. Promise. Okay? All right. So looking at this, guys, this should really help you because this is all the stuff you should really know at this point. So it says, given this function, f of x is equal to negative x squared minus 2x plus 5, we have to know the domain and range. Okay? So I took a picture of my calculator. That's the first thing I do is graph it. I took a picture of my calculator screen. So if we were to go to our calculator and type into the y equals, when we type in negative x squared minus 2x plus 5, we would get this function. Now notice this negative in front. Well, we know it's a quadratic, which is a smiley face or a frowny face. And notice the negative in front, it flips it upside down. So it's kind of interesting on how that works, okay? Now, once again, the roots are across the x-axis, just a side note. Oh no, I need to plug that in. And then we want to know the domain and range. So the domain we can tell right away, guys. Domain is x values, left and right. So with your eyeballs, left and right, where's my function growing? From left to right. Don't look up and down, it doesn't matter. Look left and right. Where's my function growing to? Left and right, guys. So it doesn't matter that it's growing down. It doesn't matter that it starts up here. I'm talking left and right. Where does my function grow this way? Negative infinity. It's growing this way forever. It's continuing. And where's it growing this way? Forever to positive infinity. So our domain on this one is negative infinity to positive infinity. And infinity is not a number. It's a place type thing. So, I'm not recording. Oh, no, I am. Okay, so we're good. All right, does everybody understand how the domain is negative infinity to positive infinity? Are you sure? Okay. Now range, shift your eyes. Now we care about how far up and down this function starts. So if you look with your pencil, it starts at what value on the y-axis? Well, that value right there, right? 6. Okay, well, we gotta look 1, 2, 3, 4, 5. It looks like it starts at 6. We gotta make sure though. And then it's growing to where? Negative infinity. Okay, I want to make sure on this value right here, because this is our maximum point, right? Does everybody see how that's our maximum point? I want to make sure, because sometimes you can't count the tick marks, because what if that was 6.01? And you put 6, just because you went off of what it looks like. So we're going to use our calculators and make sure we find the highest point first. So yeah, we do know it's growing to negative infinity, but let's make sure that we know the highest point. So this is where you'd get out your calculator and we'd find the maximum point. We've learned how to do this. So you go y equals and you type it in. So it was negative x squared minus 2x plus 5. So then I hit minus. Make sure you don't hit negative 2x. So it's minus 2x plus 5. And I hit graph. Now I want to find the maximum point, which my window's bad right now. But it is 6. You just did it? Okay, awesome. So you'll do second trace, and then I'm going to do maximum. It's the maximum value. I hit enter. So this is just to recall how to find maximum and minimums. So left bound, I'm left of it. And I believe you, Garrett. I really do. All right, and then left bound. Okay, does everybody see how our maximum is at negative 1 up 6? Look, negative 1, 6. Okay, so we know for sure this is up at the value. So it's negative 1 up 6. So negative 1, 6. So that means it's up to 0.6. So you're right, our range is, it starts at 6, and it started right at 6, and it included 6, so we put a bracket. Does that make sense? So that's why you just got to make sure, because on an ACT, they would throw something like that at you. They have the answers like 6.01, 6.001 to negative infinity, 6 to negative infinity, and 6.05 to negative infinity. And then they want you to actually type it in your calculator and make sure. Does that make sense, everyone? Yes or no? So we knew that was for sure the maximum value. So started at 6 and grew to negative infinity. Okay, next one. Find the domain, find the range. Given f of x is equal to the square root of x minus 3 plus 8. This one was really tricky, and honestly, at my other school, we would have spent a full day on graphing these kind of functions, so we're going to do that at a later date, because you need to know how to do it, and there's a lot more to it than me just briefly going over it, so I'm going to try today, and then at a later date, we'll get more in depth with this. So we have the square root of x minus 3 plus 8, guys. So what we're looking at, if you type this in on the calculator, would be this. Now, what's the hard thing is notice we can't really tell exactly where that point is, and it's not a map. It's hard to, you can't use your calculator to find that value. That's what's hard. So you have to know how these shift. So this one you'll want to pay close attention on. So I'm just going to briefly tell you, if you're like, what the heck, we'll learn it more later. But what's underneath here, what's underneath the house, that's your shift left and right. That's your shift left and right. And you always go the opposite of what the sign is inside the root, so opposite. Now this is your shift up and down, so you'll want to know this because it is on the text. Okay, so up and down, this is your shift. Whatever's added on the outside of the root is your shift up and down, and the sign stays the same. So notice, guys, so on this one, notice, guys, this one shifted right 3. So we went right 1, 2, 3. So this went right 3. Opposite. Does everyone see how right would be opposite of negative? Yeah? And then it went up 8. The sign stays the same with anything you add on the outside. So it went up to 8. So then from there you can find domain and range. But you do have to know the shifting. Does that make sense? Everybody, yes or no? Okay. So let's find the domain. Now domain is left and right, so it doesn't matter that it's growing up left and right. Where does my function start on the x-axis? Positive 3. And it did include it. It started right on 3. And where's it growing that way to? Positive infinity. All right, and the range. Now it doesn't matter how far left and right. I'm talking up and down. So this is the y-axis, guys. From down to up, where does my function start at? What value on the y-axis? 8. And it's growing to, I don't care if it's growing that way, I'm talking up, where's it growing? Positive infinity. It's getting larger and larger that way. Very good. It included 8, you put a parenthesis around infinity. Okay, questions on that one? Okay, remember that this is the shift on the inside of the root is the shift, and it's always opposite. So if it would have been plus 3, we would have went back 3. And then this stays the same. So it's not opposite, it's opposite, the same. Okay? So if that would have been minus 8, you would have shifted down 8 on the outside. Okay, and then moving on. Simplify the expression. Holy cow, you guys do not know properties of exponents, and you need to. You should have learned those in secondary 1 and then got them down in secondary 2, like hard stuff. And then in 3 should have been just a swift review. So let's go through this. Looking at this, first of all, looking at this, is there any plus signs or minus signs in the parentheses? Plus signs or minus signs in the parentheses right now? No, there's just a bunch of things being multiplied, right? So in your end answer, guys, there's not going to be any plus signs or minus signs, okay? Now, properties of exponents, that's what we're dealing with. So we've seen our little song. When you multiply, you add. When you divide, then you raise a power to a power, and you multiply. Now that song is talking about the exponents, keep in mind. All right, so once again, raise a power to a power, and you multiply the powers, not the base, the powers. What's my power on 2? 1. Okay, does everybody get how my power on 2 is 1? So we're raising a power. You see how we have 2 to the first, x to the negative second, and y to the third? And we're raising those to another power of negative 2. Raise a power to a power, and you multiply the powers, right? Okay, so we're going to multiply the powers to each of our powers, guys. So we have 2 to the 1 times negative 2. Okay, negative 2 times negative 2 is positive 4, so we have x to the positive 4. I saw people write 4 there instead of x to the 4th. And then negative 2 times 3 is negative 6. So we'll have y to the negative 6. Questions before I move on? Do you have questions, sir? Back in group 6. Okay, awesome. Good. That's what I like to hear. All right, so now we have to go through and flip all negative exponents. Now guess what? The people who got this right, they stopped here. They stopped here. But negative exponents are not considered simplified. So you draw your line and flip anything over a fraction with a negative exponent. That has a negative exponent, so we've got to flip it to the bottom. So then it's going to have a positive exponent. That's the rule of negative exponents. You flip it over a fraction, and then it makes it a positive exponent. Oh, I got to flip that. It has a negative exponent, so it's going to be y to the positive 6. Now, this is hideous. Go off to the side and write it pretty like. So we have x to the 4th on top. Yeah? X to the 4th on top. Does everybody see that? And then we have 2 to the 2nd on bottom. And now y to the 6th. Now, guys, what is 2 to the 2nd power? 4. So we have x to the 4th on top. On the bottom, 2 to the 2nd is 4. And we have y to the positive 6. Now, x and y's are different bases. You can't combine them. So you're done. But let's say that would have been an x and an x. When you divide, then you subtract the exponents. And you always subtract the top from the bottom, so we could have continued. Only if the bases are the same, though. Questions? All right. Okay, last one. Ay, ay, ay. Okay, maybe I should just give up and let you work. And then you can ask me questions. I think I'm going to let you work for the rest of the time. And then if you have questions on these, this is stuff you learned and we've learned this year. Today's a review day to make sure that we're good to go. Make sure that we're good to go. Okay? So ready, set, go. Work on the worksheet. I'm going to stop because I want you guys working and making sure you're good. Now this problem, we have talked about this. So you guys, this is just multiplication, right? Is this just multiplication? So this is just properties of exponents. So with those parentheses, they're there to trick you. You'll just reorder it in any order. With multiplication, you can. So I'll stop right after this. 2 times 3 times x to the 3rd times a to the negative 3 times y to the negative 4. And then you'll just go through and use properties of exponents to combine things that you can. Those are the only things you can combine, right? Using properties of exponents. All right, continue, and you should know how to do all of that. I really have taught you every single thing on there. Don't say I haven't, because I have. All right, ready, set, go. I'm going to come around and check homework. Okay, so today, you don't necessarily need to take notes because you know everything that we're going to learn today. So you really don't have to take notes today. You know everything. Crap. Okay, so starting with this one, it kind of looks tricky because of the parentheses, but notice there's no addition signs or minus signs in between the terms here. So we're not adding or subtracting. So guys, don't let this fool you. This is just multiplication. So we're just going to go through and multiply all these things. Now, we can really just pretend like those parentheses aren't there. Because with multiplication, we can reorder it in any order. So I'm going to put all my numbers by each other. So 2 times 3. Now, understand, you couldn't do this if there was an addition sign or subtraction sign in between these things. But there's not. So 2 times 3, and then I have an x times x to the 3rd, and then I have times a to the negative 3 times y to the negative 4. So then we'll go through and combine all like terms using properties of exponents. So 2 times 3 is 6, and then x times x to the 3rd. Well, the power on x is x to the 1st. Don't make that error. When you multiply, you add. Well, we're multiplying the same base, so we'll add our exponents. 1 plus 3 is 4. So x to the 4th. And then we have a to the negative 3 and y to the negative 4, and you can't combine those. Those are not the same base. So we still have a to the negative 3, y to the negative 4. Now our last step is to fix anything with a negative exponent. Anything else needs to stay on top. So if you look at this, you draw your line. 6 has a positive exponent. It's to the 1st power. X to the 4th power also is positive exponent. We've got to flip that and flip that. Both have negative exponents. So we're flipping them over a fraction. So when you flip it, it makes it a positive exponent. But now I'm going to remember that it's not on top anymore once you've done that. And I'm going to go off to the side and write it all pretty. So 6 to the 1st is 6, and then we have x to the 4th on top. And on bottom, we have a to the 3rd and y to the 4th. Because we flipped the negative exponents. And none of those are like bases, so we can't combine them using properties of exponents. So we're done. All right, it says, where do the graphs intersect the x? Oh, it says, where does the graph intersect the x-axis? In other words, what is the x-intercepts? When it's asking for x-intercepts, that means where does it cross the x-axis? Well, this always happens, guys. lies when y is equal to 0. So it crosses the x-axis when y is equal to 0. Now think about why that happens. If we have an xy chart here, an xy table, and we graphed a line, for example. Now it crosses the x-axis right here, and our y value is 0. Notice our y value is 0. That's like negative, for example, if it was at -2, that would be -2 of 0. So our y value is 0. So that's why when you're trying to find the x-intercept, you have to plug in a 0 for y and not x. Because our y point, when it crosses the x-axis, is 0. So I'm going to erase that really quick. All right, so we're trying to solve for x when y is equal to 0. So I'm going to go ahead and plug in a 0 wherever there's a y. So we have 2x minus 3 times 0, which is equal to 2. So then I have 2x, and then -3 times 0 is 0. So 2x plus 0 is equal to 2. So really we have 2x is equal to 2, and then solving for x, we'll divide both sides by 2. And so we get x is equal to 1. That is where it crosses the the x-intercept is where it crosses the x-axis, and it's at y is equal to 0. So if we had to write it as a point, we would do 1, 0. Our x was 1, our y was 0. All right, looking at this one, it says find the x-intercept. So it's when y is equal to 0. So we have 0 is equal to 3x squared plus 2x minus 3. Now notice, if we were trying to solve for x, we can't just quickly do this. It's a quadratic. It has the bx, so we've got to either simplify this by factoring if it's factorable, or solve by the quadratic formula. So I'm going to go ahead and just do the quadratic formula. So a is equal to 3, b is equal to 2, and c is equal to -3 in this quadratic ax squared plus bx plus c. And the quadratic formula, x equals the opposite of b. So -2 plus or minus the square root of b squared, 2 squared, minus 4 times a. A is 3 times c is -3. And that's all over 2 times a. 2 times 3. Okay, so I need some more room here really quick. Okay, so quadratics, guys, we can't just solve them quickly. We got to really do the math behind it. So I have -2 plus or minus the square root of 2 squared is 4. And then we have -4 times 3 times -3. So we're going to have notice we have 2 negatives here, guys. Notice we have 2 negatives, so that's going to make it positive. But if you type it into your calculator, -4 times 3 times -3, you're either going to get a positive or negative answer, and that's what you'll just put down automatically. So don't do double dip by putting minus a negative if you're doing it this way. If you type it in -4 times 3 times -3 into your calculator, -4 times times 3 times -3, you get positive 36. So you're going to say positive 36. Now once again, if we would have got -36, we would have just put minus 36 there instead. But we got positive 36, so we'll do plus 36. And that's all over 2 times 3 is 6. So we have -2 plus or minus the square root. 36 plus 4 is 40. And that's all over 6. We got to keep simplifying. This is where we go off to the side and we say, okay, what is the square root of 40? Can we break that down? If you put that into a calculator, guys, you get a decimal. And we know if we get a decimal, we've got to try to go through and break this down by hand so we can get the pretty answer. 4 times 10 is equal to 40. 4 breaks down into 2 times 2. And 10 breaks down into 2 times 5. Now, because it's a square root, we're pulling out groups of 2. So if there's a group of 2, it can leave the house. So we're pulling out those 2 2's on the outside of the root. Now, do not pull out 2 times 2. You didn't pull out 2 times 2. The only reason you pulled out a 2 is because you had 2 of them. So we pulled out a 2 that accounted for those 2 2's there. And then we have a 2 and a 5 left. There's no other 2's or 5's to pull out groups of 2 with. So they've got to stay under the house. And whatever stays under the house is going to go back to its original form, which was 2 times 5, so 10. Essentially is under the house. So now keep in mind, guys, that 2 square roots of 10 was just this piece. Remember, I went up to the side to simplify it. So I have -2 plus or minus 2 square roots of 10 all over 6. Now, some of you on accident are floating the 2, this 2 out front with the front 2, and that would be incorrect, guys. It was outside of the root, right outside. So this whole thing became 2 square roots of 10. So don't put it in front of the plus and minus sign. It wasn't. It was behind it. It was plus and minus the square root of 40. And the square root of 40 is equal to 2 square roots of 10. So just notice how I put it in the right place right here. Right here. Okay, so now let's simplify it. Now, if all 3 terms can divide by something in common, you need to do that. So notice I have a negative 2, and then I have this plus or minus 2 square roots of 10, but the square roots of 10 doesn't count. We leave that alone at this point. And then we have all over 6. So they all 3 divide by 2. So I'm going to go ahead and do that. So 2 divided by 2 becomes 1. So we have a negative 1. 2 divided by 2 becomes 1. And then 2 divided by 6 and becomes 3. So what I have here then, if I write this out again, I have negative 1 plus or minus 1 square roots of 10 all over 3. Now, understand that x is equal to. Now, understand that on a test, they're not going to write 1 times the square root of 10, guys, is just the square root of 10. So what we have is x is equal to negative 1 plus or minus 1 times the square root of 10 is just the square root of 10, and then it's all over 3. So once again, this just means negative 1 plus the square root of 10 over 3 and 1 minus the square root of 10 over 3. So now those are the x-intercepts where it's crossing the x-axis. So once again, that's just a number. If you typed it into your calculator, you do negative 1 plus the square root of 10, and then you'd hit enter, and then that's divided by 3. So it's crossing at 0.7207592201. But like I said, you guys, now that we're in secondary 3, they want this answer. It's much prettier than plus and minus, then 0.7207, and then if we did negative 1 minus the square root of 10 and hit enter, divided by 3. And then the other answer, if we actually did this out, would be negative 1.387. Now notice, obviously, that answer is the same as these answers, but this is the answer now that we're in secondary 3 that they would expect you to be able to do. All right, moving on. All right, solve by factoring. Before we can even solve by factoring, our quadratic has to be set equal to 0. Once again, it's quadratic because it's degree 2, so I'm going to subtract 9x from both sides to get it equal to 0. I would always suggest keeping the sign in front, not a negative, so that's why I didn't bring the negative x squared over. I brought 9x over because I like to keep it not a negative in front of the squared, x squared. So I'm going to subtract 9x from both sides. So I have x squared minus 9x is equal to, those added to be 0. That was the point. Now from here, we can do this the long way or the quick way. So once again, if you look first in a quadratic, what do I have in common from the very beginning? Notice in this quadratic, we have an x in both terms. So if we factor out an x, we've got to write what's left inside the parentheses. So once again, if you go back through and divide each term by x, it's going to help you know what was left inside. X squared divided by x is x. Negative 9x divided by x is negative 9, so x minus 9. Now look, these are our linear factors. These are linear. They're both degree 1. So now that we have our linear factors and we have it set equal to 0, we can split them apart and set each of them equal to 0. So we'll set x equal to 0, x minus 9 equal to 0, and solve for x in each case. X is equal to 0 is already done. Got to do a little bit more work on this one. Add 9 to both sides, so x is equal to positive 9. Okay, so we found our 2 solutions, and we knew it had 2 because of the square. State the zeros and include their multiplicities. So once again, guys, we have to remember that x minus 3 cubed times x plus 1 squared times x minus 2 just means, if I wanted to write this out the long way, x minus 3, x cubed means x minus 3 times x minus 3 times x minus 3. And then x plus 1 squared means x plus 1 times x plus 1. And then we have our x minus 2. Now those are linear factors. We can set them individually equal to 0 and solve. So looking at this, if we set this equal to 0, we would get, so x minus 3 is equal to 0. If we solve for x, we get x is equal to 3. Now that's the same thing, that's the same thing. So we'll get x is equal to 3, x is equal to 3. We got that 3 times. And then with 1, we set x plus 1 equal to 0, and then we solve minus 1, x is equal to negative 1. We will get that again there. And then we get x minus 2 is equal, I'm going to change colors. So we get x minus 2 is equal to 0, and so we add 2 to both sides, x is equal to 2. So then from here, you and say, okay, I got x is equal to 3 times, and I got x is equal to negative, x is equal to negative 1 2 times. So now we can say, this is how you write your answer. X is equal to 3 with multiplicity of 3, because it happened 1 2 3 times. And then we get x is equal to negative 1 with multiplicity of 2. It happened 1 2 times. And then we got x is equal to 2. And you don't have to stay with a multiplicity of 1 because we only got it once, so we're good. All right. State the zeros and their multiplicities, then determine what is the degree, the number of terms, and the coefficients. So first of all, it says state the zero. So a lot of times we have these wordy problems. You have to just work through them in pieces. So it says state the zeros and their multiplicities. So this is similar to the last example. So notice what we have here is 3x times x minus 1 squared means x minus 1 times x minus 1. Now you'll set your individual factors equal to 0. 3x is equal to 0, and x minus 1 is equal to 0, and x minus 1 is equal to 0. Solve for x in each case. Divide both sides by 3. 0 divided by 3 is okay, because 0 is not on the denominator of the fraction. 0 divided by 3 is 0. Add 1 to both sides, so x is equal to 1. Add 1, so x is equal to 1. So now we know that our roots are x is equal to 1 with a multiplicity of 2, because it happened twice. And then we got x is equal to 0 as well. And once again, you only have to write that one time because what we're doing, I mean, if you only have it once, that's fine. You just have to state the multiple multiplicities. Okay, now we gotta go through, oh, I should have kept that top part there. So now I'm gonna erase this to give myself some room to show you this next part. So now it says, what's the degree? Well, you know, a lot of us can look at this and say, I see it's gonna be degree 2, but let's say you didn't know for sure. You got, oh, degree 3. This one's degree 3. So this one's a little bit trickier. We got to go through and do some work here. So we have 3x times x minus 1 times x minus 1. So we're multiplying 3 things here. Now, I'm going to have you make sure you take my suggestion. Multiply 2 things together first, and then multiply the third thing in last, because you'll miss something if you try to do it all at once. So I'm going to focus on this piece and multiply this out. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x, and then negative 1 times negative 1 is positive 1. I'm going to, before I multiply 3x in, I'm going to combine all like terms here. So I have x squared, and those negative x's don't cancel out. They become negative 2x's plus 1. Negative x minus another x is negative 2x's, and then we won't forget that we have to multiply 3x to all that stuff. So now what we'll do is distribute 3x times x squared, careful, is 3x cubed, and then 3x times negative 2x is negative 6x squared, and then 3x times positive 1 is plus 3x. So then from here, we'll combine all like terms, and we're done. So now we know this is degree 3. The number of terms we have is 1, 2, 3. Terms are separated by plus or minus signs. So terms, 1, 2, 3 terms. And then the coefficients are the numbers in front of the variables. So we have a 3. So I'm going to, let me click on this. I have a 3, a negative 6, and a 3. So 3, negative 6, and 3. And we're done with that one. Okay, so it says solve the equation below. So we've got to go through, now notice this is a big, messy equation. It's a linear equation. Notice everything with x's are degree 1. So that's kind of nice because we like solving linear equations rather than quadratics. Quadratics take a lot more. But we got to do this correctly. So first of all, we have a negative in front of this, x plus 4. Now, what you need to understand is the negative is only multiplied to x plus 4. It's not multiplied to this 2x. Look at it. It's in parentheses for a reason. Okay? So I'm going to simplify the left first, simplify the right, and then we can go through piece by piece. So focusing on this piece here, I'm going to go ahead and rewrite that as negative 1, and I'm going to distribute it through. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. And then we won't forget about our plus 2x that was still on the left. Okay, let's focus now on the right side here. Let's combine all like terms. Now be careful. You can't do 20 minus 3 first and then multiply it in. That means if you do that, if you do 20 minus 3, then you do 17. And if it's not 17 times x plus 4, because this is being multiplied. So you absolutely have to multiply -3 first. So I'm going to go ahead and do that. So -3 times x is, now be really careful because if you're going to distribute the negative through with it, once you write it down here, you're not going to double dip on the negatives. So -3 times x is, sorry, I'm going to change, well, no, let's stay with this. -3 times x is -3x, and then I have -3 times 4. I can't forget to multiply that -3 to everything in the parentheses. So -12. And then we won't forget about the 20, it was still there. Now once again, don't double dip on the negatives. You took care of it by multiplying it through when we multiplied it through here, so don't double dip there. So now once again, on the right, I'm going to combine all like terms. So we'll have -x's plus 2x's, which is +1x's. So we still have, so I combined -x plus 2x, which is +1x. If I need to write the 1x there, it's not a big deal, but I'm hoping that we're getting past that. And then we still have our -4 here, which is equal to, I'm going to combine like terms, so 20 minus 12 is 8. So 20 minus 12 is 8, +8 minus 3x, and we still have that. Now we're going to solve for x. Now we have an x on the left, we have an x on the right. We need to bring them together, but we got to use the correct operation to get it from one side of the equation to the next. So now on the left, I'm going to combine like terms. 1x plus 3x is 4x. So we have 4x minus 4 is equal to, once again, I just combined those. Those add up to be 0, so it's equal to 8. And we're solving for x piece by piece, so I add 4 to both sides. So I have 4x is equal to 12, and then we'll divide both sides by 4. So x is equal to 3. That was a lot of steps, guys. You have to be really careful. I'm thinking our algebra is getting better and better, though, every time we do these things, because I'm seeing less errors. Be careful, though. Okay, couple more. Last one, I believe, actually. Yeah, last one on the video here. So we have x to the -2, y to the third, z to the -5th, all raised to the -1. The first thing I need you to understand, there's no addition or subtraction signs in there, so don't add them in there. Now this is just properties of exponents since there's not an addition sign or subtraction sign. So what we'll do, guys, is sing our property of exponent songs. When you multiply the same base, you add the exponents. When you divide the same base, you subtract the exponents. Raise a power to a power, and you multiply the exponents. So if you look at this, we're raising powers to another power, so you multiply the powers. So we're going to go ahead and just say, okay, we're raising that to the -1, that to the -1, and that to the -1. And when you raise a power to a power, then you multiply. So we'll have x to the -2 times -1 is +2. Y to the 3 times -1 is -3. And then z to the -5 times -1 is z to the +5. Then we have to look at it. Okay, well, x, y, z, those are not the same bases, so we can't combine those any further. But we do know we have to fix anything with a negative exponent. So it looks like the only thing with a negative exponent is our y. So when we flip it over a fraction, it makes it a positive exponent. So on top, we have x squared, and we have z to the +5. And now on bottom, we have y to the +3 because we fixed our negative exponent. And we're done. Thank you for watching the video, and I hope you enjoy it.